Assalamualaikum students. I hope you will be good students. And I'm here with another question. This question is previous two questions were very easy. Okay, I did first easy questions, and now this question is not difficult, but it's a bit, as compared to those two questions, it's not that much easy. Okay, and let's start this question. This paper is, I hope you know the paper, you see the paper. Paper is 9709 and question paper 3 and your October November 6 is the paper. Okay, that's the question paper. And question number 10. Okay, let's start the question. They say that okay, they say that the diagram shows the curve y is equal to x cos 2x for x is less than or equal to 1 over 4 pi and greater or equal to 0. The point M is a maximum point. Okay, show that x coordinate of M satisfies the equation 1 is equal to 2x tan 2x, and marks here are given to us. There are 3 marks. Okay, this is a very easy part. The first thing here, which you should know, is the point M is a maximum point. So there are two things in derivatives. One is minimum point and one is maximum point. So I hope you know the maximum point characteristics and the minimum point characteristics. At both these points, dy dx is equal to 0. Okay, at minimum point, the gradient is 0 at minimum point, and at maximum point as well, the gradient is 0. So you should know these things first. Okay, then let's go to the question now. Fine. Function given to us is, what's the function? I'm doing the question here because there's no space. We'll start from here. Okay, this is the old paper, and old paper format was that they were not giving space for solution. So yeah, that's clearly visible, I think. Y is part 1, y is equal to x cos 2x. Now, let's differentiate this. Dy dx. Now, if somebody says, sir, how we know that we will do differentiation? Look, this is very clearly mentioned here that the point M is a maximum point, and show that the x coordinate of M satisfies this thing. It means they have done something here, and they got from that thing, they got this thing. And since they mentioned the maximum point of M, so it means this is a signal that we will do differentiation. Now, this first function, and that is second function. Now, first function, derivative of second function is minus sine 2x. I don't know why this is moving. Sine 2x, and again derivative of 2x is what? 2. Because you know the derivative of cos x is minus sine x. Now, and then plus cos 2x, derivative of x is 1. So we get dy dx is coming with us. We're getting the result here. Cos 2x minus 2x sine 2x. Okay, fine, that's the result. And since they say gradient at M is 0, so I will replace this thing with 0. I get here cos 2x minus 2x sine 2x. Now, here's a problem. Here's some problem in this. It's moving. When I'm writing the things here, then that thing is starting movement. Okay. I don't know what's the reason here. Okay, so you will replace this with 0. So dy dx is equal to cos 2x and minus 2x and sine 2x. Yes. Now we can bring this thing. We can also say that 2x and sine 2x is, I'm bringing it here, and cos 2x remains there. Okay, now so I can also say that I'm doing part 1. So I can also say cos 2x is equal to 2x sine 2x. They want this thing. See, they want 1 here, and on that side they want 2x tan 2x. So if you think how we can generate tan 2x here, so tan x is sine x over cos x. So dividing both sides by cos 2x and cos 2x, I got here 1 is 2x tan 2x. That's the result. So you got 3 marks for this thing. This was 3 marks work. Now next part 2. The equation in part 1 can be rearranged in the form. Okay, they have rearranged this equation. They have given the red equation to you, and they say use the iteration formula. Part 2 I'm doing here. Part 2 is xn plus 1 is equal to 1 over 2 tan inverse 1 over 2 xn. Fine. They say use this. This is iterative formula with us. This iterative formula, sorry. Okay, they say use this iterative formula, and then we should then get what? They say use this iterative formula, and the initial value of x is 0.4. To calculate the x coordinate of m, correct to 2 decimal places. Give the results of each iteration to 4 decimal places. It's very simple thing. Now see here. You know, x1 is already given to us here, 0.4. So if n is, now see, I will need x2. So n1, I will use n1. So this becomes 1 plus 1 is equal to 1 over 2 tan inverse 1 over 2 x1. That's the thing. Now just put the value here. Put the value for x1. So 1 over 2 is giving you basically x2 now. This is x2 now. 1 over 2 tan inverse 1 over 2. The result for x1 is what? 0.4. Now this thing gives me, I'm using calculator here now, 0.5 in and tan inverse 0.5 tan inverse fraction 1 divided by 2 into 0.4 and closed. So we get, I'm getting here 0.448. They say take each iteration to 4 decimal place. So we get here 0.448 and 0. That's the first iteration. Now for second, I will need here x3 then. So I'll be here, I'll be writing 1 over 2 tan inverse 1 over 2 x2. Now the result is 1 over 2 tan inverse 1 over 2. This is 0.4480. So result comes 0.5 into tan inverse fraction 1 divided by 2 into 0.4480, and that is the result, which is 0.4201. Yeah, I'm getting 0.4201 here. Here I'm getting 0.4201. Yes. Now I will need x4, 1 over 2 tan inverse 1 over 2 x3. Fine. So 1 over 2 tan inverse 1 over 2 here is 0.4201, and the result should be, now here I will replace this by 0.4201. Yeah, so the answer coming 0.4360. 0.4360, yes, 0.4360. Now I will need x5. Okay, x5. X5 here. X5 is 1 over 10, 1 over 2 tan inverse 1 over 2 x4. So 1 over 2 tan inverse 1 over 2 x4 is what? 0.4360. That's the result. And 0.5 tan inverse fraction 1 divided by 2 into 0.4360, bracket closed, 0.4268, 0.4268. Okay. Now, see here, x6 I'm doing 1 over 2 tan inverse 1 over 2 x5. Put the result, I will get here. Uh, 0.4268. What I get? I get 42.43. Sorry, 0.43. 0.43 and 21. Yes, and x7. Similarly, x7 is, see, I'm getting 4268, 43. There I got 4360. Here I'm getting 4268. Again, I'm getting 4321. Now see what is 7 giving, x7 giving me 1 over 2 tan inverse 1 over 2 x6. So the result is, put x6 here. Point 0.4321. Now 0.4290 I'm getting here. 0.4291. Yeah, 91 I got. So let me do one more. x8 1 over 2 tan inverse. So yeah, 1 over 2x7. Yes, so this gives me, I will just replace that with the 0.4291. 0.4291. 430. See, I got 4308. Yeah. So now see, 4342, 4342, 4342. So let's stop here because almost we are near to the. See, when the difference is very less. See, this is now 4291 and 4308. Now here is very less difference here. So then we stop there, and almost like we are doing till 7th iteration till 8th iteration. But if the difference is very much less in 5th or 6th iteration, we can stop even there. So that's the result. And they say give the answer to decimal place. So our answer is x coordinate of m is 0.43. Yes. 2 decimal place. That's the result. I hope it's clear to all. Now let's go to the next part. This part I will not be having space, but I will do something for this. I'll be doing small writing here. Okay, I will make line here first. Part 3. Part 3 is, they say find the, you can go to the question. Use integration by parts to find the exact area of the region enclosed between the curve and the x-axis from, yeah, fine. Look, the curve and the x-axis from the point, they say basically this. This is the area enclosed by the curve, the x-axis, and from here to here. So very simple question. This is basically integration from 0 to pi over 4, and the equation is x cos 2x and dx. Now, before doing the question, I'll be giving you some information and some rules. You know, if I take these are two functions. If I take this one first function and that one second function, it will be difficult for me to do this integration. Okay, so I will say to you, no, don't do this thing. I will erase it. I will say, okay, take this one first and that one as second equation. So then students can ask, sir, which one should we take first? Which one we should take second? Because like now you're telling me to take that one first and this one second. But if we are doing the question ourselves, how we will know which one should be taken second, which one should be taken first? Is there any rule or guidance or some instructions for that? Yeah, I will give some instructions to you. Look, there is one simple instruction: I, L, A, T, E. Always follow this thing. I is for inverse trigonometric functions, and L is for log functions, and A is for algebraic functions. Algebraic function means x square, 3x square, x power n. Log function means log x and log x square and blah blah blah. And this is trigonometric function means sine, inverse x, cos, inverse x, and so on. Okay, and T means trigonometric functions, trig functions, and E means exponential functions, like e power x, a power x, and e power x square, and so on. So these are, you should remember this. Now see here, this is, I'm erasing it. Here is, you see the question, this is log function and that is trigonometric function. Now check log and trigonometric, sorry, algebraic function, algebraic, this is algebraic, and that's trigonometric function. So algebraic is here and trigonometric is here. Which one is first? Algebraic is first. See, this is first and that is second. Okay, in the order it's fourth, but here algebraic first and trigonometric second here. So here we will say, when the first one, we will take first function. This is 1 and that is 2. Now see here, I will start here integrating this. So I will, the rule for integration by part is what I'm writing here: a, b, dx. So if you are taking this one and that second function, so first function integral of second function, the dx sign should be dx sign, you will write the dx sign there, minus whole, see this thing, you will take the whole integral of this thing now. See this thing, so a whole integral of this thing but just take the derivative of this as well. Okay, and this whole will be again taken dx here. I'm giving example now. Look, if I have x square and ex, then I will erase this example because I don't have space. Look, algebraic and exponential. So algebraic is first, see, algebraic is first. Look at that, algebra and exponential. Algebra is coming, you will start moving from left to right. So algebra is coming first, then second is at the end, exponential function is coming here. So you will take it 1 and that one 2. So now integrate this thing, we will say dx sign here. We will say, sorry, we will start this with students. First function, x square, integral of exponential function. Okay, dx comes here, that's a rule. Minus, I told you, see, derivative of this. So I will be again taking the whole integral of the whole, but I will take the derivative of this first. So d of derivative of x square, and then see this thing will bring it as it is. Bring this thing as it is, okay? And ex and dx, and whole dx is coming there. So we get x square, integral of ex is again coming ex, okay? And we can say it, derivative of x is coming here 1, so that's 1, minus derivative of x square is 2x, integral of ex is coming ex over 1. So, and here is dx. Now again, x square ex minus 2 x and ex dx. Now this thing is again, this is x is algebraic and ex is exponential. So algebraic will come first, okay? Algebraic will come first. I'm doing this one here, ex, sorry. X and ex. So this will be first, that will be second. So first x, and then integral of ex dx minus, I told you, write a big integral sign and then bring this whole thing there, but take derivative of this x, dx of x here, and ex and dx is already there, and then take whole dx as well. Now boys and girls, students, don't have space here, so I'm compelled to erase this thing. You will have, I hope you have copied this thing. So I will erase this part because I need some working here. Now, so this becomes, I'm bringing it here. This becomes, look here, x, this is x, integral of ex becomes ex, and minus whole derivative of x is 1 and integral of ex again ex, and I have told you right here whole dx. So x ex minus, now it's ex and dx. So x ex minus ex, that's the result. Okay, so this was just example. Now I will come to the question. I hope you will be you understood this method. Now I will be doing this part 3, which is integration part, and I'm erasing all these workings. Okay, all this working. I'll not erase the ILATE. And for learning it, you can say ILATE. Okay, ILATE means ILATE, ILATE. Now, if you see ILATE rule, and if you compare here both, so x is algebraic function and cos 2x is a trigonometric function. So algebra is coming first, and then trigonometric function is coming. So we will take it first, and trigonometric function will take second. So first function is x, and second function is trig. So first function is first x, and integral of cos 2x dx. The range is given to us there, 0 to pi over 4, minus, I have told you, take this whole thing, bring it here, but take the derivative of x. So derivative of x and integral of cos 2x and whole dx here. Okay, fine. So x here, or you can say this way, first function integral of second function minus whole integral derivative of first function integral of second function. This is also, this you can say also this way. So x integral of second function is minus sine 2x over 2, and see range is given to us here 0 and pi over 4, and minus it's 1, and that is sine 2x, but negative sign here, okay, and divide by 2, and dx is coming here. So x sine 2x minus sine here, minus coming here over 2, and minus, this minus comes here plus, so I will write again this thing, sine 2x over 2 dx. This becomes minus x sine 2x over 2, and limit is 0 and pi over 4, plus 1 over 2. Integral of sine 2x is again, look, derivative of cos derivative is minus sine. Okay. Fine, ठीक है. Okay, fine. Oh, मैंने यहाँ पर कुछ mistake किया थोड़ा सा. I will just fix it again. Okay. I did mistake here. That shouldn't be coming negative there, because the derivative of cos is minus sine. So integral of cos is not coming minus sine. Remember that thing, please. Okay. I did mistake here. That is not negative. This is not negative. Okay. This is not negative. Now again, this is not. That's the rule negative, and this negative is not coming here. Fine. And this is again positive. Negative, sorry. That is negative of the rule. Ab yahan par I will erase this part, then I'm going to say one rule to you now. Derivative of cos is minus sine x. Derivative of sine x is cos x. Now, derivative of cos is minus sine x here. Okay. So integral of cos will not be minus sine. But if you are taking integral of sine, see, integral of sine is cos. Derivative of sine is cos. So, but integral of sine will be minus cos. I hope you know this thing. So here now, minus 1 over 2, and integral of, see, integral of sine 2x and sine 2x. Sine 2x and dx. So here I will do x sine 2x over 2, and here is 0 pi over 4, and minus 1 over 2, and integral of sine 2x is what? As I said, this will be minus cos 2x over 2 now. So, and limit is 0 to pi upon 4. So the result becomes, students, all right, the final answer here, the final integration here, x sine 2x over 2, and here is 0 and pi over 4 limit, and plus here 1 over 4 cos 2x and limit is 0, pi over 4 here. That's your integration now. Now students, when we got integration, now we can apply the integral here. We can apply the limit here, which is I'll apply here. See students, apply it here. You can apply it to yourself, but I'm doing it here. See, I'm just making this line here. Look, I'm bringing it here. So for this thing, for first part, pi over 4 sine pi over 4 into 2 is 2 into pi over 4. Okay, and here is divide by what? Divide by 2. Then minus 0, and the whole thing becomes 0 then. So this is the first part. Second part is plus, look, 1 over 4 cos 2 into pi over 4 and minus cos 0. So I hope you got this thing. 1 over 2 I'm bringing here, pi over 4 came here, and sine 2 into pi over 2 is pi over 4 is pi over 2, and plus 1 over 4 cos pi over 2 and minus cos is minus cos 0. Minus cos 0 is cos 0 is, yeah, cos 0 is 1. Cos 0 is always 1. So you can say, okay, this 1 over 4 is basically common. This 1 over 4 is basically common. Okay, this 1 over 4 is common. You should remember this thing. So now come on, get the result yourself, please. Please result yourself. I'm sorry, I was not having space. I just did it this way, but basically the understanding, for understanding you should, for basically you need understanding of the concept, and you need understanding of the question and the rule and the method. So you can do it yourself now, and I hope you will be clear about the question, about the methods, about the rules. So inshallah, I will meet you in next question. Thank you so much.